Like adding a relationship between two ends of a many-to-many, when changing or removing these relationships, the focus is on changing or removing the join between the two ends, but the two ends stay intact. Because we're using skip navigations, that join isn't directly available to us as an object. And that means you'll need both ends of that relationship in memory so that you can remove one of the objects from the other's list and let the change tracker figure out how to respond to that in the database. And again, because each end is equal in the relationship, neither one is principal or dependent, it doesn't matter which end you focus on. You may recall that we assigned two artists, Dee and Pablo, to work on one of the covers. Well, Pablo has decided that Dee is such a great talent that she won't need his help, so he's going to bow out of working on that cover. I'll take advantage of the fact that I know the cover ID is 1, and I can write a query against the cover's DB set, include the artists, but I'll filter the include to only bring back the artist that I want to remove, Pablo, whose artist ID also happens to be 1. I could have included all of the artists, which in my database won't affect performance at all because there are only 2. But what if you have hundreds of items in this relationship? If all you need to work with is this one relationship, then there's no need to waste resources retrieving, materializing, and tracking every single one of those to perform this simple operation. So filter, I will. Since I only have a single item in the artist's property, and it's the one I want to remove, I can use the list remove@at method and point to the item at index 0. Alternatively, I could capture the specific object in a variable and use the remove method instead of remove@, passing in that variable instead. And keep in mind that I'm not using an EF-core method here. This is only removing the item from the list of artists in the artist's property method. So the change tracker does not yet know about this. And next, because it's really informative and useful when you're learning and debugging, I'll go ahead and call detect changes and grab the short debug view so we can take a look at that before calling save changes. As I'm running this now, just to be clear, there is only one artist in this collection, and it's Pablo. So I am 100% sure that this is the item I'll be removing from the list of artists. After I call detect changes, the debug view shows me details for 3 change tracker objects. Numbers 2 and 3 are expected. Those are the artist and the covers that I queried for, and those are unchanged. I'm not doing anything to either of those objects. My focus is on the join between them. And that's represented in this first item, which is for artist cover. And remember that the data model is aware of an entity called artist cover, even though we don't have that in our own code. And EF-core is tracking that entity in its knowledge of the relationship between the artist and the cover. And the entity is marked deleted. So by removing the artist from the cover, in response, EF-core knows that it needs to get rid of the join between them. Okay, so finally, I'll call save changes, and there's the resulting SQL, a delete command to get rid of that particular row in the join table, the one whose artists and cover IDs are both 1. So far, I've focused on deleting the relationship, but what if you want to delete one of the objects that's in the relationship? For example, you need to delete a cover, but it's been assigned to an artist. Many-to-many relationships also subscribe to cascade deletes by default. So if the full relationship is being tracked, in other words, you've got the cover and the artist in memory, and therefore EF-core is aware of the join between them, then EF-core will delete the join along with the cover. If you only have the cover in memory, so the change tracker isn't aware of the join, then EF-core will only send a delete for that cover to the database. But the database will then cascade delete the row in the join table for you. So with skip navigations, that's really the best path to disconnect two ends. I do have to say that it would be a lot simpler to just delete the row in the database directly instead of going through all this work. Now, granted, in your application, you may already have all those objects in memory, so you wouldn't have to go about explicitly getting them from the database. But if you don't have them in memory, especially in the case where you already know the IDs of both ends of the join, it's another reason to stick around for the module on using database views and stored procedures a little later in this course. What if you need to change a relationship? For example, reassigning a cover from one artist to another. You saw me do this with a one-to-many relationship, but there's a big difference here. When I moved a book, my data model was defined such that a book could only ever have one author. EF Core knew it had to change the author ID of the book. But with a many-to-many relationship, a cover can belong to multiple artists. So you have two separate joins you need to deal with. You need to remove the existing join and then add a new join between the cover and the other artist. This method, reassign a cover, takes a cover whose ID is 5 and is associated with the artist whose ID is 4. I'm going to disassociate them, removing the artist from that cover. Then I've retrieved the artist whose ID is 3, and now I'm adding that artist to the cover's artists collection. And we'll just check the change tracker this time instead of running it on the database. The first item showing in the debug view is an artist cover join entity to be added for the new combination of artist ID 3 and cover ID 5. And then the next is an artist cover entity that needs to be deleted. That was the original one. And of course, the artist and cover objects are all there, but they're unchanged. So if I were to call save changes, the row representing the original join will be deleted and the new one will be added. And in the end, the cover will now be reassigned to the new artist. Now that you've gone through the basics of working with the most common style of many-to-many relationships using skip navigations, I do want you to have some awareness of the other two ways to map a many-to-many with EF Core. One of these extends the skip navigations, but allows for some payload data, and the other is to create and use an explicit class in between the two ends. So this will just be a light intro to those. The reason you would use either of these other two mappings is if you want to track more information in that join. For example, if you need to know when an artist was assigned to a cover or when the artist signed a contract for the cover. There may be a point where you have so much more data you want to collect about that assignment that you would just create a new class called assignment and connect it to the join entity. But if you just have a limited amount of data that makes sense to contain in that join, then these are the patterns you should consider. One of these mappings extends the skip navigations and let you have database or DB context-driven data included in the join. This additional data is referred to as a payload. What does that look like? First, you'll create a class to represent the join. And believe it or not, you won't be using this class in your code. Only EF Core will work with the class. This class needs to have the two IDs that reference the other entities. I might name this class Cover Assignment, and within it, I'll have an artist ID and a cover ID property. Now, the extra payload data is not something that you'll be able to code against outside of the DB context. So this is not a pattern if you want to have something like the date that the artist signed the contract. Someone would need to be able to specify that. But what if you want to have an audit trail for when that join was created in the database? That's a good use case for skip navigations with payload data. But in order to track it, we'll need an additional column that the simple skip navigation doesn't provide, which is why we need to have a class somewhere to put this property, and I've added the date created property to my cover assignment class. So how do we get that column populated? By specifying that the date created property maps to a column in the database that has a default value, for example, SQL Server's getDate function. Another key ingredient of this pattern is that it will not be recognized by convention. There's nothing in the artist or cover class that connects it to the cover assignment class, and the cover assignment class has no knowledge of the artist or cover class. For example, it doesn't have any navigation properties. So EF Core will just continue with the skip navigation that we were already using, unless you explicitly map this in the DB context on model creating. The configuration is pretty complicated. So I'll leave this in the sample code for you to look at if you're interested. And you can learn more about how to construct this mapping in the EF Core docs, which I'll link to this specific page in the resources. But I do want to highlight a few sections of the mapping. Here I'm referencing the relationship between artist and cover. This using entity method is how I'm telling the context to use the cover assignment class for the join instead of inferring that. Then I have a few more mappings specifically for the cover assignment entity. One is that because I want the date created column to use the SQL Server getDate function to provide its data, I'm using the hasDefaultValueSQL method on the date created property of our new class. And because I want it to use the existing artist cover table, I'm using the toTable mapping to ensure that. And finally, because I named the IDs in the new class Artist ID and Cover ID, but they need to map to the existing columns in the Artist Cover table, I have mappings here to indicate the column names for the mappings. While the DB context needs to be aware of the cover assignment class, you won't be working directly with it, so there's no need to add a DB set for cover assignment in pub context. I won't be demonstrating this in action, but if I were to create and run a migration, then the existing artist cover table would be modified with this new column. And then I could just continue interacting with artists and covers as I've done already. The artist and cover class are totally unaware of the cover assignment class, and you just don't work with that join class in your code. But the data model knows about it, and anytime I join an artist and a cover and save that, the database will be sure to put the date into the new column. The final way to define a mapping has also existed through the entire history of Entity Framework and Entity Framework Core. Rather than ask EF Core to handle the join internally, you design your classes similar to how the database is structured, with an explicit class that connects the two. And like the database mapping, that class has a one-to-many relationship with each end, but those ends have no direct knowledge of each other. And with this join class, you can put as many additional properties as you want. You'll have access to this in code, so this is where you can have logic like the date that a contract was signed. Having an explicit join entity in the mix gives you very granular control over the relationship. However, it adds a layer, or two or three, of complexity to querying and building those relationships. If you want to query the relationship, you have to navigate through that join entity. There's a lot to learn about working with it, and I've actually covered both of these patterns in more depth in earlier courses, such as EF Core 2 mappings and EF Core 5 getting started. And I anticipate these being covered in other courses in the EF Core 6 path. But don't forget to go check the official docs, which also provide more in-depth detail. Many-to-many relationships are a very common pattern in our business domains, and I really appreciate that EF Core gives us a variety of ways to implement them depending on your needs. Skip navigations are the most natural way to express many-to-many in our classes, and while it might seem like magic when EF Core is able to interpret that into a relational database structure, it really isn't magic. There are just some very smart APIs supporting that capability. But the skip navigations are definitely the easiest to use for querying and adding data. Granted, due to the nature of many-to-many, it's a little more cumbersome to remove relationships, but now you know how to get that done. And if you need to track more information about a join, you saw that it's possible to add payload data while continuing to benefit from the ease of skip navigations. And when you need to pull out all the stops, you can always go back to describing the relationship as a pair of one-to-many relationships with a join entity in between. Although doing that will require more effort to code up your queries and connect objects on either end of the relationship. There's one more type of relationship we need to address, which is a one-to-one relationship, and the next module will focus on that. Here are a number of resources that I've mentioned in this module, including more information on mapping many-to-many relationships, and on the second page, links to some more information about creating indexes for foreign keys if you're interested in learning more about why migrations only created an index on one of the columns in